So we're going to discuss systems of linear inequalities. Last week we looked at systems of equations where we had two equations and then the solution is the points where the two lines intersect. When we graph an inequality, we have each inequality creates a shaded region, and then the solution to the inequality is where the two shaded regions overlap. So to graph y is less than 2x minus 1, the first thing we do is graph the boundary line, y equals 2x minus 1. So we graph our boundary line. And then, so this has a y-intercept of -1 and a slope of 2. So since we have y is less than 2x minus 1, so this is less than but not equal to, that means we're going to use a dotted line because it's saying we're not including this line as our solution. Sorry, my line is not very straight. And then since it's less than, we're going to shade all of the parts that are below the dotted line. So everything down here is a solution to the first inequality. So when we have it solved for y, so if we have y is less than mx plus b, like we did here, then that means, so it's less than, so we shade below. So this would be shade below and a dotted line. But if we had less than or equal to mx plus b, we would shade below still, but with a solid line. And then if we had greater than, then it's vice versa. Or we would, so greater than or equal to would be a solid line, but shade above. And then greater than, but not equal to would be a dotted line, and you shade above. So this one, if we solve this for y, we get then we can do 2y is greater than -4x plus 8, and then y is greater than or equal to -2x plus 4. So we have greater than, so we're going to use, so we have greater than or equal to, so that makes it a, that's going to make it a solid line. So we go to, our y-intercept is 4 and our slope is -2. We use a solid line to indicate that the points on the line are still a solution. And then we shade above, so over here. And then the solution to the whole system of inequalities is where I have both of these colors overlapping. So both of my shaded regions have overlapped. So the solution to the system is this area in here, which is now green. So keep in mind this, the shading below, shade above, only works if we've solved the equation for y. We can graph systems of inequalities using the intercepts method, which can sometimes be a little bit faster, but sometimes a little more confusing. So first, to graph both of these lines, let's graph their intercepts. So the intercepts, so I'm going to ignore y for a second, right? So if I get -6x equals 12, that makes my x-intercept My x-intercept is -2. And so now y is back, and I'm going to make x equal to 0. Then I can see that my y-intercept is +6. And now that's another way to get my 2 points to graph the line. So my x-intercept is -2, so that's here. My y-intercept is +6, that's up here. And then since it's greater than or equal to, that makes it a solid line. And then to determine which way I'm going to shade, so the equation isn't solved for y, so I can't use the trick that I used over here. But what I can do is test a point. So the line divides the coordinate plane into 2 areas, right? We're going to have one side of this line is going to be shaded, and one side's not going to be shaded. And we don't know which is which yet. If we test a point, and then the point comes out to work, so if we tested the point 0, 0, and 0, 0 satisfies the inequality, then we would shade this part because 0, 0 worked, so all the points on this side have to work. And if 0, 0 didn't work, that means we're going to shade the other side because all of the points on the other side have to work. If 0, 0 doesn't, that means none of the points on this side of the line work. And 0, 0 happens to be the easiest point to test because if we plug in 0 for x and y, we're going to get the statement 0 is greater than 12. So I'll write that down. So 2 times 0 minus 6 times 0 is greater than 12, which is not true. So we're going to shade 0, 0 is not shaded. So 0, 0 is here. We're going to shade everything on that side. So now let's graph the second one. We get, again, if we use our intercepts method, that makes our y-intercept is going to be 2. And our x-intercept is going to be, if I cover up y, I can see that x would equal 4. So I come over and I graph the 2 points. So x-intercept is 4, y-intercept is 2, and this one is a dotted line because that's greater than but not equal to. And if I use my 0, 0 test again, so I would have, so 0 plus 2 times 0. 0 is not greater than 4. So that means, again, 0, 0 is not in the shaded region. Now for the second inequality. Now for the last one, we have x is less than -2, which is really the easiest one because we would graph the line x equals -2 and dotted because it's less than but not equal to. So we graph a dotted line. And since we're just looking at x, the numbers less than -2 would be to the left. So we would shade over here. And then we can see the part where all three overlap is up in this top left part. All right, last thing we have here is a word problem. So we have, we need to buy filing cabinets, and cabinet X costs $10 per unit and requires 6 square feet of storage space. And cabinet Y costs $20 and requires 8 square feet of floor space. And we have only $140, and we have only 72 square feet for cabinets. And we want to write and graph a system of linear inequalities that models the situation. So in order to do this, first let's figure out what are the variables here. And the variables are the types of cabinets. So conveniently they're named X and Y. So X is our cabinet X, and Y is our cabinet Y. And one constraint that we have is we can only spend $140. So our cost has to be less than or equal to 140. And we know the cost of each cabinet, so that means 10x plus 20y has to be less than 140. And our other constraint is our floor space. So our square footage has to be less than or equal to 72. So then, since cabinet X takes 6 square feet, and cabinet Y takes 8 square feet, 6x plus 8y has to be less than 72. And that's our system of inequalities. And then we also have, we can't buy a negative number of cabinets. So common sense tells us that X and Y both have to be greater than or equal to 0, which is why we only have the first quadrant of the graph here, right? I didn't put any negatives. So now we just have to graph the system of inequalities. So our intercepts for the first one. So this first one is going to have an x-intercept of so 10 times 0 plus 20y plus 140. Then we get a y-intercept of 7. So here's our y-intercept. And then our x-intercept is going to be 10x equals 140. So x is 14. And we use a solid line. And then for our 0, 0 test, we would get 0 times 10 plus 0 times 20 is less than 140. So we get that 0 less than 140. So 0, 0 is shaded. So we shade this part. And for our cabinet Y, or for our, so that was our money constraint. So for the square footage, we get our x-intercept is going to be 72 divided by 6. And then our y-intercept would be 72 divided by 8. So our x-intercept is 9. And our y-intercept is 12. So we have here and here. And that line almost went through that point. And again, we would get, if we test 0, 0, it's going to work. So we're going to shade everything down here. And then, so if I look at where they overlap, I have this quadrilateral, right? And the last thing it says is interpret the meaning of the solution area. So what we have is this is all the possible combinations of cabinets that we could purchase, right? So the points in the solution region represent the possible numbers of cabinets that we, or the possible numbers of each cabinet that we could purchase. So we can purchase 6 X's and 4 Y's. We could purchase 2 X's and 2 Y's, but we could not purchase 2 X's and 10 Y's. So the solution region represents possible combinations of cabinets.